there's a lot of material, but it's not too difficult, and I can't remember when the test will be. I can't remember if somebody saw it. Oh, it's the Monday before Thanksgiving. So there's, what is that, 2-3 weeks?
Yeah.
So there's some material on here, and today what we're going to do is we're going to continue on with what we did last time with the ionic compounds, except now we're going to do it non-metal with non-metal. And you have to be quiet. All right, so there's some vocab. You can refer to that, and we'll talk about some of those things a little bit later on. When we start writing chemical formulas, or I'm sorry, chemical equations, which we'll do once we get back from winter break or Christmas break, whatever you want to call it, whenever we see any of these standing by themselves, in other words, not with anybody else, but with its own kind, sounds kind of weird. These are what we call diatomic molecules. So if I say, hey, there's some hydrogen in the air, we don't say there's just one hydrogen atom, it's actually paired up. And a lot of people are like, why is that? Well, it's the way God made it. So these things don't float around by themselves, they're always paired up. So there are I think there's 7 here. Yeah, there's 4 and 3. Exactly, so you need your swim buddy, travel buddy, whatever it's called. And the easiest way to remember this, when it's by itself, and that's really key, when it's by itself, if it ends in I-N-E, ein, or if it ends in gen, G-E-N, then it's diatomic when it's by itself. Okay, so I-N-E or gen. So hydrogen, nitrogen, oxygen, bromine, fluorine, chlorine, okay, things like that. If it ends in I-N-E and it's by itself, in other words, it's not with somebody else, then it's diatomic. Okay, and we'll talk more about that when we write balanced equations. I honestly don't know why I put it in the notes at this point right here. Rules for writing formulas. A lot of this should be the same that what we talked about before we left for break, which was an awesome break. I like these 2-week breaks. Rule number 1, again, represent each kind of element in the compound with the correct symbol. Now, I think part of the problem, if you didn't do well on your test, is because you don't know your 52 elements yet. Names and symbols, you've got to know those. Again, use subscripts to tell how many of each atom. We did that with the ionic. We will do it the same with the molecular. Number 3, write the symbol that's more metallic first. Now, since we're only working with nonmetals, this rule really makes more sense. Because back when we did the ionic, we said, yeah, metals are over here, nonmetals are over here. If it's a metal, write it first. However, in this case, we have to look at the more metallic element. Now, it doesn't mean that it's a metal just because it's more metallic, which is kind of weird. Yeah. So when we look at it, it decreases as you go from left to right, and it increases as you go down a periodic table. So if I say I'm comparing, say, carbon, which is right here, to, say, oxygen over here, which one's more metallic, the carbon or the oxygen? Carbon, good. So we always write the carbon before the oxygen if we're putting those two together. Now, if we're looking at, say, sulfur, which is right here, I'm sorry, oxygen, which is right here, and sulfur, which is right here, which one's more metallic, sulfur or oxygen? Sulfur, so we'd write the sulfur first. Okay. Now, what's very nice is we'll never have 2 elements that are diagonal from each other. So you're like, wait a minute. For whatever reason, we don't do that. Or if we do have that scenario, I'll write it out for you. Okay. And here's an example showing sulfur dioxide. Again, in this case here, it's called sulfur dioxide, and we'll talk about the dye here in a moment. But sulfur is the more metallic element, so we write it first. Oxygen is less metallic, so we treat it as a nonmetal. We do not care about charges. When we have nonmetal with nonmetal, charges are out the window. So you don't have to worry about, oh, wait a minute, they both have a -2 charge. How are we going to balance the charges? We don't. And that's the nice thing about this prefix that we have right before the oxygen. It tells us how many we're going to have. And you're going to get to memorize that here in a moment. And again, all of these were found experimentally, so you don't have to try to figure out, well, how in the world did they figure that out? All right, naming binary molecular compounds, or nonmetals with nonmetals. Probably the first thing we have to do is recognize who the nonmetals are. So go ahead and get your periodic table out. I'm sure you do already. And if you have something, and again, I'm not looking for a fat Sharpie, but if you have something like a very thin Sharpie or a pen that you can write on your periodic table, I'm going to have you draw the non-metal triangle. Here's what we're going to do. Triangle has 3 sides or 3 points. So I want you to put a dot directly in the middle of the carbon. Put a dot right there. Then your second dot goes directly in the middle of the F for fluorine. Then the last dot goes smack dab right in the middle of the I in iodine. Then what I want you to do is connect the dots using a straight line. Is that what they call that? It's a triangle, right? Okay. So you should have a nice triangle here with a 90-degree angle at the fluorine. Okay. So middle of carbon, middle of fluorine, middle of iodine. Okay. So this is our non-metal triangle. Now again, binary, hopefully everybody knows what binary is, 2. Okay. I'm not asking you to do binary codes or anything like that, which is nice. With nonmetals, or binary molecular compounds, and we won't name any compounds that have more than 2 nonmetals, which is nice, until you get to organic chemistry. But again, we do not care about the charges. Since we don't care about the charges, there has to be some way for us to address to those who care how many of each of the nonmetals we have. So that's why we have these Greek prefixes. Okay. So from number 1, we use mono. In other words, right now is a good time of year for you to get your furnace checked, because if it's not functioning correctly, it could produce what type of toxic gas? Carbon what? Monoxide. Oh, mono. Got it. Okay. When you're sitting in here and you're breathing, you take in oxygen and you breathe out what? Carbon dioxide. Okay. So the Greek prefixes you've been using, you just haven't really paid attention to it. All right. So make sure you know the Greek prefixes. So 1 is mono, 2 is di, 3 is tri, 4. Anybody play Tetris? That's an old game. It's a good one. The 4 squared thingy. Okay. So Tetris. And then from there it gets pretty simple. Penta 5, hexa 6, hepta's kind of a weird one, 7, and then octa. Now I know that there's nano and deca, and they keep on going, but for what we're doing, we're only going to go up to 8. Okay. So if there is something more than 8, say, Mr. Craig, you said that we're only going to go up to 8. We can live with that. Okay. So you'll have to memorize these. This will be the difficult part of doing this work today. That's the difficult part. Because hopefully you know your 52 elements, names, and symbols. Yeah. Well, not even that. You just need to know carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur. Yeah. All right. So here are the rules. Again, name the elements in the same order that they appear in the formula. So if I'm giving you a formula like the SO2 that I gave you, name them in the same order. Number 2, drop the last syllable, or in some cases, last 2 syllables. Okay. And add IDE, which is kind of nice because that's what we did before. Number 3, add prefixes to the name of each element to indicate how many we have. Except what we don't do is we don't use mono for the first element. Okay, like we talked about carbon monoxide, and the symbol or the formula for carbon monoxide is CO. We don't call it monocarbon monoxide. Okay, if there's at least 1 for that, then we just drop the mono on the first element only. Okay. Same thing with the CO2 for carbon dioxide. We don't call it monocarbon dioxide. But if we had more than 1 element for the first one, then we have to tell everybody how many we have. Okay. So mono, we drop for the first element. And here's an example. CO2, the carbon dioxide. So again, write and I wouldn't do this every time. Hopefully you'll get into the pattern of recognizing what you need to do. So we have carbon and oxygen, and then we're going to drop the last syllable or last 2 syllables and add IDE, so carbon oxide. And then we're going to add the prefixes to represent each, monocarbon dioxide, and then step 4, mono is dropped on the first element. So this is what's going on in your mind when you name these things from now on. This almost took about 10 minutes. All right, what's the name of this compound, N2O4? Dinitrogen. Again, we only dropped the last syllable, the last two syllables on the second element. So we're going to leave the first one as is. So since we have two, it's di. And if you want to hyphenate, because I like to hyphenate, and that just cleans up from saying, is there two O's, is there two A's, whatever. Just hyphenate it. Di, di, dash, and then nitrogen. And then what's this last one here, the O4? Tetroxide. Very good. So dinitrogen tetroxide. Okay. What's A? What's SI? Silicon? Or silicone? I don't care how you say it. And then, so since there's only one of those, we're not going to say monosilicon, just silicon. And then what's the second thing here? Mono. We'll drop the un and add ide. Carbide. So silicon monocarbide. Sounds manly, doesn't it? Silicon monocarbide.
All of them in an ide?
They will, yes. Because there's no polyatomics here, there's no ionics. So all of these better end in ide. Okay. Good question. B, CS2. So what is C? Carbon. Carbon disulfide. Okay. Carbon disulfide. So again, the sulfur is sulfide, and then since there's two of those, disulfide. Okay. C. So SF6. Sulfur hexafluoride. Very good. Letter D. Silicon dioxide. Very good. All right. Letter E. Letter E. Di who? Not bismuth. Diboron. Trioxide. Very good. Diboron trioxide. Letter F. Dinitrogen. Remember, the ide is only on the second one. So dinitrogen. Remember, what is that place in Washington that the military's in? Yeah, the Pentagon. So pentaoxide. So dinitrogen pentaoxide for F. G, here we go. Good. Tetrasulfur hexaoxide. Aren't those fun? And you, for whatever reason, your notes has a 9 on there. That should be an 8 for H. So P5Cl8. So what is H? Pentaphosphorus. Octachloride. Good. Everybody good with that? Yeah, not too bad. All right, number 2, write the formulas for the following compounds. And you'll notice that I hyphenated all of these, just so that you're not going, is there one O or two O? Who cares? It's all right. All right, so how would I write letter A? Chlorine dioxide. ClO2. Good. And you'll never have a carbon followed by an iodine. Okay, I won't do that to you. So if you see it, and I didn't put any chlorines on, yeah, I did. Okay, so whenever you see what might, in your mind's eye, think that that's a carbon and an iodine, that's really a chlorine. Okay, hopefully you'll remember that. Letter B, dichlorine monoxide. Cl2O. Very good. Letter C, triphosphorus tetraoxide. P3O4. Letter D, tetrasulfur dinitride. Good. That's 4N2. Letter E, iodine heptafluoride. 7. Hepta and hexa you have to keep in order. I don't know how you're going to be able to do that. I guess hepta has more letters, so yeah. And the letter 7 has an E in it. I don't know. Now I did throw arsenic in here, but I won't do that to you on a lot of those. F, what is tetraarsenic octaoxide? Good. AS408.
Wait, is arsenic part of our triangle?
It's not, but those things, the arsenic, the silicon, those are metalloids, which can swing either way. They can either act like a metal or a non-metal. So in this case, they're acting like a non-metal. All right. Where are we at? H, tricarbon hexachloride. C3CL6. And H, I think. H, C3CL6. Did we not do G? No. Okay, sorry. So pentasilicon heptaoxide. Si5O7. Good. And then I, phosphorus monochloride. PCl.